Hello friends, welcome back. In today's lecture, I am Dr. Milind Meshram, working as an assistant professor in the Department of Chemistry, CHEM College, Nashik. In the last lecture, we have discussed the alcohols. Okay, we have discussed introduction, then classification of alcohol. Okay, and then we have seen the IPAC nomenclature, and thereafter we have discussed structure and shape of alcohols. In this lecture, we will discuss the preparation of alcohols. Okay, we will see the different methods for the preparation of alcohols. Most of the simple alcohols can be prepared by using industrial method. Alright, and complex alcohols are prepared by using several methods. Okay, there are several methods available in the literature. For example, Grignard synthesis, ester hydrolysis, and reduction of carbonyl compounds. Carbonyl compounds such as aldehyde, ketones, esters, and acid. Alright, so let us start with the Grignard synthesis. So there are three main methods for the preparation. First one is Grignard synthesis, okay, which involves the Grignard reagent. Alright, this is the one of the most important method for the preparation of alcohols. Okay, when Grignard reagent, suppose this alkyl or aryl halide reacts with magnesium turning in the presence of CHEM, it gives Grignard reagent. Okay, this is the Grignard reagent. Alright, so this is the Grignard reagent, organometallic compound, alkyl or aryl magnesium halide. Alright, so here formaldehyde will give the primary alcohol, acetaldehyde will give secondary alcohol, and ketone will give tertiary alcohol. On the other hand, ethyl format, that is ester, will give secondary alcohol, and other ester will give tertiary alcohol. So first of all, we will see the formaldehyde. Formaldehyde will yield primary alcohol. Alright, suppose this is the formaldehyde, and this formaldehyde reacts with, for example, phenyl magnesium bromide, so it gives this phenyl group is having partial negative charge and this magnesium partial positive. Okay, it will attack like this, so we would get this OMgPr. Okay, this is the complex. Then after hydrolysis, okay, so we get this CH-302, okay, plus this Mg BrOH. Okay. So this is the primary alcohol. Primary alcohol. Since this alcohol bonded, since this hydrogen group attached with primary carbon. Okay. So this is the primary alcohol. So that means this, when you react phenyl magnesium bromide with formaldehyde, this is the formaldehyde, so it gives primary alcohol. Okay. In the first step, this complex will form, followed by the hydrolysis, it gives the primary alcohol. And when you have the acetaldehyde, so in that case, you will get the secondary alcohol. So let us have this reaction. When we have this acetaldehyde, this is acetaldehyde. When you react this acetaldehyde with ethyl magnesium bromide, like this, this is the complex. Then subsequent hydrolysis can generate this secondary alcohol. This is the secondary alcohol. When you have this acetone, react with ethyl magnesium bromide. Okay, so this is the ethyl magnesium bromide. Grignard reagent. Okay, Grignard reagent to get this is the complex. Followed by hydrolysis, it generates tertiary alcohol. Okay. So when you have the aldehyde, that is acetaldehyde, the product will be the secondary alcohol. And when you have the acetone, when you react with ethyl magnesium, when this acetone reacts with ethyl magnesium bromide, it gives this complex. Then subsequent treatment with acid hydrolysis, it will give the tertiary alcohol. All right. On the other hand, when you have the ester, generally except this ethyl format, the ester generally gives the tertiary alcohol, because in the ester will react at 2 moles of Grignard reagent. Alright. So in the first step, it will generate ketone, and ketone is more reactive, so it react with another molecule of Grignard reagent, it will generate tertiary alcohol except ethyl formate. Alright. On the other hand, when you have the ethyl acetate and reacts with Grignard reagent, it will generate tertiary alcohol. For example, ethyl acetate react with methyl magnesium iodide, okay, like this. Then this you will get this ketone. Okay, this is the acetone. Then this acetone will react another molecule of Grignard reagent, so it will generate this salt. Okay, this it will generate this complex. Alright, after hydrolysis it produces this tertiary alcohol. Okay, so this is tertiary alcohol. So when you have this ethyl acetate, this is the ester, and you react with methyl magnesium iodide, in the first step it will generate this acetone, okay, and this ketone is more reactive. Then it will react with another molecule of Grignard reagent, that is methyl magnesium iodide. So it will generate this complex. After hydrolysis using this mineral acid, it will give the tertiary alcohol. This is the one of the important method for the preparation of alcohol. One more method is hydrolysis of esters. So let us see that method. Hydrolysis of esters. Okay, when you have this ethyl acetate reacts with HCl, okay, it will give the hydrolyzed product. For example, acetic acid plus ethanol. Alright, ethyl alcohol. That means when you have this ethyl acetate, this is the give the corresponding acid and alcohol. Okay, so here we can prepare this ethyl alcohol in this way. So let us have another example. For example, ethyl benzoate. For example, ethyl benzoate. Okay, when this ester reacts with HCl, it will give this ethanol plus benzoic acid. Benzoic acid. Alright, and ethyl alcohol. So this is the another method. So one more method is reduction of carbonyl compounds. So carbonyl compounds such as aldehyde, ketones, esters and acids. So we can prepare the alcohol by using the reduction of carbonyl compounds. So there are several reducing agents used in the reduction of carbonyl compounds. Reduction of carbonyl compounds. Carbonyl compounds like aldehyde, ketone, acid, esters, okay, etc. So there are various reducing reagents like lithium aluminum hydride, sodium borohydride, NaHg in H2O. Okay, the reduction of aldehyde and ketone. Okay, and the reduction of aldehyde by using lithium aluminum hydride, sodium borohydride, NaHg, H2O, then H2 in H2 nickel. Okay, it will give the primary alcohol, whereas this ketone will give the secondary alcohol. So when you have this acetaldehyde, and you react with lithium aluminum hydride, it will give primary alcohol. Okay, primary alcohol. So that is ethyl alcohol. Alright, when you have this acetone, when you react with sodium Hg, water, so it will generate secondary alcohol. Okay, so this is the secondary alcohol. That means isopropanol. So this is the primary alcohol. Primary alcohol will generate from the acetic halide by using reduction with lithium aluminum hydride. This primary alcohol can be prepared from ester and acid as well. Okay. So when we have this acid and ester, when you react with lithium aluminum hydride, so it will generate the primary alcohol, reduction of acids and esters. Suppose we have this ethyl acetate, when you react with lithium aluminum hydride, so it will generate the ethanol. Okay, this is the primary alcohol. Also, when you have this benzoic acid and reacts with lithium aluminum hydride, it will give this primary alcohol, that is benzyl alcohol. Okay, so this is ethyl alcohol and this is benzyl alcohol. Okay, both are primary alcohol. Alright, so here acetic halide will give primary alcohol and ketone will give secondary alcohol. On the other hand, this ester will give primary alcohol and this acid also will give primary alcohol. So this is also one of the most important method for the preparation of alcohols. Alright. So this is all about the today's lecture. In the next lecture we will discuss physical properties of alcohols and chemical properties of alcohol. Thank you.